Alright guys, we are going to be talking about chemical reactions. In this particular unit, we've already seen all the different types of chemical reactions. We've talked about how to balance chemical equations and how to write them. And we're going to be looking at one specific type of chemical reaction in this specific video, which are single replacement reactions. So a single replacement reaction, as we've seen, is a reaction in which the atoms of one element replace the atoms of another element in a compound. So we have element A, usually a metal, is going to replace B in the compound. So as you can see, A comes in, bonds with the anion X, and then B gets kicked out and becomes a single element by itself. Now, because of what's called the activity series, a metal will not always replace a metal in an aqueous compound because of differing reactivities. So we have to use this activity series to determine if the single replacement reaction will occur. In order for the reaction to occur, the element has to be higher on the list. It has to be more reactive than the element in the compound. So we're comparing all of these different metals, and as you can see, the reactive metals are at the top, the unreactive metals are at the bottom. There is hydrogen in the list. Hydrogen almost always acts like a cation, like the metals do, so we can actually use hydrogen as a metal, in quotes, being a cation, and it's included in the activity series. So let's take a look at how that activity series works. So what we want to do is we want to predict the products that will result when these reactions happen, and we want to write a balanced equation for each reaction. Now, before we can actually do that, we need to consult the activity series and make sure that the reaction really will happen. So if we're looking at the activity series, what we need is we need to make sure that iron is more reactive than copper, that iron will replace copper in this reaction. So if we look at our activity series, we find iron, it's right here. We find copper, it's way down here. So yes, iron will replace copper. Iron is more reactive than copper. Now we want to figure out what our products are going to be. So if iron is going to replace copper, then we know for sure that solid copper is going to be one of our products because it's getting kicked out of the compound. So solid copper is going to be produced. And then the iron is going to react with the sulfate and become iron sulfate. Now in this particular case, we need to know the charge of iron because it's a transition metal. I'm going to tell you that this is iron 3, so it's going to be Fe with a +3 charge. So we'll make a little note up here, Fe +3. And we know that sulfate, SO4 -2. So when those two things combine with each other, we get Fe2SO4 3, and this one's going to be aqueous. So those are our two products. The iron's going to replace the copper. We're going to get solid copper and iron sulfate. And then we want to balance our equation. So we're going to need 3 here, 3 here, and 2 there. Okay, there's our balanced equation. All right, in the next example, we want to look at zinc reacting with HCl. Now here is where our hydrogen will come into play. So look at your activity series. Is zinc higher than hydrogen on the activity series? The answer is yes. So the zinc is going to replace the hydrogen. Now, when hydrogen gets kicked out of an equation, it becomes just plain old elemental hydrogen. And if you remember, hydrogen is one of those 7 diatomic elements that exist in nature as 2 hydrogens bonded together. And so over here in our products, we're going to have to write it H2, and it's going to be a gas. So in this particular reaction, if you're creating a gas, what would you expect to see happening in your container? You would see bubbles of hydrogen gas being formed, whereas up here, you would actually see solid copper being formed. Okay, so now zinc is going to react with chlorine. Zinc has a +2 charge. Again, I'm telling you that it's a transition metal that you would have to be told what the charge is. Look at the periodic table. Chloride has a -1 charge. Put zinc and chloride together, and you get ZnCl2. It will be aqueous. And then when we balance, we would need a 2 right there. Okay. Last example, solid magnesium reacts with aqueous calcium chloride. So go back to your activity series, find magnesium. Is it more reactive than calcium? The answer is no, it is not more reactive than calcium. Magnesium is lower on our activity series, which means we will get no reaction. This reaction will not happen. If you put magnesium in a solution of calcium chloride, nothing's going to happen. They're just going to sit there because magnesium will not replace calcium in that particular reaction. Okay, let's talk about oxidation-reduction reactions. Single replacement reactions are considered oxidation-reduction reactions. And since we're talking about them, combustion, synthesis, and decomposition reactions are also considered oxidation-reduction reactions. And these reactions, which we are going to use the kind of abbreviation redox to represent oxidation reduction, it's just a little bit of a simplification. Redox reactions involve the transfer of electrons from one atom to another. So what we have happening here, if we take a look at magnesium reacting with oxygen to produce magnesium oxide, as you can see, this is a synthesis reaction. Two reactants are making one product. The magnesium atoms are losing electrons. The oxygen atoms are gaining electrons. So we are transferring electrons from magnesium to oxygen, which makes this a redox reaction, an oxidation-reduction reaction. So here we would have the magnesium ion, which is now a +2 charge, the oxide ion, which is now a -2 charge. They bond with each other because opposite charges attract and produce magnesium oxide. So that transfer of electrons makes that particular reaction a redox reaction. All right, let's look at another example. Now, this is going to be a single replacement reaction. Chlorine is going to replace the bromine. So here we're not dealing with metals, we're dealing with halogens, which happens every so often in a single replacement reaction. So in this particular reaction, we have the bromine ions, which are here. They're going to be giving chlorine gas electrons, so there's a transfer of electrons. Bromine's going to turn into a liquid, chlorine is going to turn into an ion and bond with the sodium. So we have a transfer of electrons again, making it a redox reaction. Okay, now let's define these things. Oxidation is defined as the loss of electrons. Reduction is defined as the gain of electrons, and they both have to happen. One thing loses electrons, the other thing gains electrons. You can't have one thing without the other, so they happen at the same time. And to help you remember which is which, we're going to use the little mnemonic oil rig. Oxidation is losing electrons. Reduction is gaining electrons. Okay, we're going to pause right here. In the next video, we're going to take a closer look at oxidation and reduction reactions and how we tell what's being oxidized and what's being reduced. So go to the next video and you can finish with these particular notes.